Laplace Transforms Mixed Problems on Properties. Hello future engineers and my dear students, welcome back to Mudassir Academy. In the previous videos on Laplace Transform, we saw three major properties with respect to the VTU syllabus and examination point of view. So let's have a quick recap of those three properties. So please lend your ears to me. My words are programmed to fit in your brains. So listen carefully. The first property was any equation in Laplace transform is multiplied by e raised to at. Say L of e raised to at into f of t. That e raised to at has no involvement in the answer. It means simply what is beside that e raised to at f of t. Say it can be e raised to 2t into sin t, e raised to minus t into cos 3t sin 2t, something like this. Okay, e raised to 2t to t square. So e raised to at into f of t. What's beside that e raised to at f of t? Find the Laplace of that, and after finding the Laplace, in the answer replace all the s by s minus a. Which a? That a belongs to e raised to at. That's all. Okay. The second property was any equation in Laplace transform is multiplied by t raised to n. Say Laplace of t raised to n into f of t, t sin t, t square cos 2t, so what we do here, we use the formula Laplace of t raised to n into f of t is equal to minus 1 raised to n d raised to n by ds raised to n Laplace of f of t. See what is the meaning of this? When any equation in Laplace transform is multiplied by t raised to n into something, t raised to n meaning is it is not involved in the answer. Its meaning is whatever is beside it, find a Laplace, differentiate how many times n is given. If t is means 1 time, t square 2 times, t cube 3 times, so on. Differentiate once, twice, thrice, and that answer multiply by minus 1 raised to n. So if it is only once, multiply by minus. If it is 2, minus 1 the whole square is plus. Okay, that's it. Now the property number 3 says any equation in Laplace transform is divided by t upon t, sin t by t, cos 2t minus cos 3t by t, something like this. Then numerator by denominator is t here. Upon t means we use a simple formula Laplace of f of t by t is equal to integration s to infinity. Whatever numerator Laplace is there, find the Laplace of that into ds. That's it. And to make it more easy, I had also given the formulas. So integration 1 by s ds is equal to log s, integration 1 by s plus a is equal to log s plus a, integration of s by s square plus s square ds is equal to 1 by 2 log of s square plus s square, and integration of a by s square plus s square is equal to tan inverse s by a. Okay, that's it. Fine. So now today's video is the extension of those properties. Today we are going to solve some next examination questions based upon those properties. So if you haven't watched those videos, please find the link in this discussion below or refer the playlist. Questions like this: find the Laplace transform of 2 raised to t plus cos 2t minus cos 3t by t plus t sin t are frequently asked in the examination. Particularly this question has been asked many times. So practice this question perfectly with me so that you don't lose marks in the examination. And before solving this question, if you are new to this channel and if you haven't subscribed, then please hit the subscribe button. This would provide me the greatest help and courage and boost me to make such more videos for you even in my present health conditions. So again the question is find the Laplace transform of 2 raised to t plus cos 2t minus cos 3t by t plus t sin t. So let's apply Laplace to it. So we have here Laplace of 2 raised to t plus Laplace of cos 2t minus cos of 3t by t and plus Laplace of t into sin t. So let's solve this now. So first Laplace of 2 raised to t, there is no property in this. See, we have learned the basics of Laplace. In that I given some formula. We can write, I write here, a raised to t is written as e raised to log of a into t. What is that? A raised to t can be written as e raised to log of a into t. Fine. So here I can write 2 raised to t as Laplace of e raised to log of 2 into t. And this is a very simple formula, standard formula. Laplace of e raised to at is 1 by s minus a. So log t is constant here, that is a is log 2. So 1 by s minus a. So this will be 1 by s minus log 2. So it is done here. The first thing is done. Again now plus. Now the second, tell me what? Cos 2t minus cos 3t by t. So as I discussed with you, what is that? This is property number 3. division by t property. Any equation in Laplace transform is divided by t upon t in the denominator, then you need to use the formula s to infinity Laplace on the numerator ds. That's it. Okay. So we have here s to infinity. What's that? Laplace of cos 2t minus upon t means s to, meaning of upon t is s to infinity. So we have solved this question earlier, like Laplace of cos at minus cos bt by t will be log of root of s square plus b square by s square plus square. Okay. So here only numbers are given. So s to infinity, Laplace of cos 2t is s by s square plus 4 minus cos 3t is s by s square plus 9 into ds. So let's first solve this. So direct integration formula you are aware of, integration of s by s square plus a square is what? Log 1 by 2 log of s square plus a square. So this will be, when I integrate, integration sign goes 1 by 2 log of s square plus 4 minus 1 by 2 log of s square plus 9, and the limits are s to infinity. Okay. Now again 1 by 2 is common, it will be outside, 1 by 2 common outside, fine. So 1 by 2 is common outside. So again I write directly here, log a minus log b will be log a by b. Please refer the previous videos for this property. Okay. So log a minus b will be log a by b. So I write directly here, 1 by 2 is common here. So this will be log of s square plus 4 by s square plus 9, and limit from s to infinity. Now it's time to apply the limit. See, the top limit is infinity and bottom limit is s. Bottom limit, okay, no issue, but top limit is infinity. As I discussed earlier, so when infinity is there, anything by infinity is 0. So you need to, when there is infinity, you need to compulsory apply the limit and bring that infinity down. So how we do that? So we take this as 1 by 2. So first, for this we will apply limit of log of, as s tends to infinity, s square plus 4 by s square plus 9 minus, in place of s put as it is. So this will be log of s square plus 4 by s square plus 9. Okay. Now if you solve this, we get 1 by 2 limit as s tends to infinity. So log of, what we do, we take s square outside, 1 plus 4 by square upon s square into 1 plus 9 by square minus, this will be as it is, we will replace s by s as it is, s square plus 4 by s square plus 9. Fine. Now here this cancels, s square cancels. Now see, anything by infinity 0, then put here 4 by 0 infinity, sorry, 4 by infinity 0, 9 by infinity 0. Am I right? 4 by infinity 0, 9 by infinity 0. So it will be log 1. What is log 1? Log 1 is 0. Log 1 is 0. So this becomes 1 by 2, 0 minus log of s square plus 4 by s square plus 9. Okay. Now, so 0 minus, so what I do, I take minus 1 by 2 outside, it will be better. So minus 1 by 2. Again this would be minus 1 by 2. What is again log a by b? Log a by b is log a minus log b. So log of s square plus 4 minus log of s square plus 9. Okay, s square plus 4 minus log of s square plus 9. Now again if I open the bracket and bring the minus sign inside, minus into minus here, minus into this minus becomes plus. So log of s square plus 9 will come first. So we have this as 1 by 2 log of s square plus 9 minus log of s square plus 4. Now again log a minus log b is log a by b. So this will be 1 by 2 log of s square plus 9 by s square plus 4. Fine. So till here you get. Again, if you remember, there is a property in logarithm. The property was log of a raised to k is equal to k log of a. Right? That means if you have, that means k log is log a raised to k. That means 1 by 2 k log m is log raised to. So this will be again now log of s square plus 9 upon s square plus 4 raised to 1 by 2. So write this later, raised to 1 by 2 means it is root. Okay. So this is the answer. Fine. Now we'll solve for this. So here again plus, this is what? This is property number 2. Any equation in Laplace transform is multiplied by t raised to n into f of t minus 1 raised to n. What is n? 1. D raised to 1 by ds raised to n Laplace of sin t. That is, what is Laplace of sin t? Laplace of sin it is a by s square plus a square. So sin 1t is 1 by s square plus 1. So this will be now again minus bracket differentiate this. So again we use the quotient rule. So quotient rule will be, put a big bracket here, denominator square. Okay. So what's the quotient rule again? I write it for you. Differentiation of first by second function is equal to second function square, second as it is into differentiate first minus first as it is into differentiate second. Okay, fine. So denominator second square, second as it is square, as it is, differentiation of 1 is what? Cost 0. 0 minus 1 as it is, differentiate square is 2s. Now series minus to minus become plus. So this will be now plus 2s divided by, this is 0 only, minus minus plus s square plus 1 the whole. So now we have the answers here. So this is one answer, this is 1 and this is 1. Therefore let's combine the answer together now. So we can write, therefore write Laplace of 2 raised to t plus, I write in a single line the answer here, Laplace of 2 raised to t plus cos 2t minus cos of 3t divided by t plus t into sin t is equal to, so what's the answer? 1 by s minus log 2, 1 by s minus log of 2 plus, say I write this in standard form. What does that mean? See, log raised to 1 by 2 means anything raised to 1 by 2 means root. In the more you can keep as it is, no issue, this is correct answer. But in the more standard form, you can write as log of root of s square plus 9 upon s square plus 4 plus finally 2s upon s square plus 1 the whole square. This is the final answer. That's all. That's the answer. I hope you understood how to solve this. Okay, but see, what you can do is you can do this separate, do this separate, do this separate, add it. I have the board here. I had done everything. I found it 2 raised to t here, cos 2t minus cos 3t here, and here, and added them. So this is my final answer. That's true. See, the next question here is very interesting question. Find the Laplace of t into e raised to minus 2t sin 4t. So let's solve this question. So remember one thing, when they give mixed questions like this, say here t into e raised to minus 2t sin 4t, the exponential function is said to be the most easiest one. So always take it first. Remember the trick here. So when they give mixed things, always take e first. The ongoing problems will be very, very easy for you. I'll show you how. So what I write this as Laplace of e raised to minus 2t into t sin 4t. Fine. So I will solve this problem in a very beautiful way, step by step. So first what I'll do, let's find the Laplace of sine 40. So we have this as sine 40. Am I right? So first Laplace of sine of 40. So I am solving step by step here, is equal to, what is Laplace of sine 80? A by s square plus a square. So 4 by s square plus 16. Okay. Now the next one is who? It is t into, see, t into sine 40. So what does t into sine 40 means? T into something, t into f of t means property number 2, multiplication by t raised to n property. That is, Laplace of t raised to n into f of t, as I discussed, is equal to minus 1 raised to n d raised to n by ds raised to n Laplace of f of t. So let's do it here. So next one is Laplace of t into sine 40 would be minus 1 raised to 1 d by ds, only one time differentiation of the Laplace of sine 40, that is 4 by s square plus 16. So let's find it. Again, use the quotient rule. Differentiation of first by second function is equal to the denominator second function bar, second function square, in the numerator second as it is, differentiate the first minus the first function as it is, differentiate second. Listen carefully. So this will be now how much? Minus, differentiate this now, put a square bracket, quotient rule, denominator square, s square plus 16, the whole square, s square plus 16 as it is, differentiation of 4 is 0, minus 4 as it is, differentiation of s square plus 16 is into 2s. That's it. Now s square plus 16 0, minus into minus plus, 4 into 2s 8s. So minus into minus will be nothing but plus 8s divided by s square plus 16 the whole square. Now finally, what? For sine 40, then into t, and lastly full question Laplace of e raised to minus t 2t into t into sine 40. So that implies Laplace of e raised to minus 2t into t into sine of 4t will be what? See, again first was sine 40 into t means property number 2, that is multiple of t. Here into e raised to t means property number 1, shifting property, right shifting property. Any question in Laplace is multiplied by e raised to t into f of t. We already found f of t here, that is t to sine t. Then what? Replace all the s by s minus a. If of what? E raised to t. Here a is minus 2. So here replace what? S by s minus of minus 2, that is plus 2. Understand? Replace s by s plus 2 since. Getting it? Therefore, the answer here becomes, replace all now, 8 into s plus 2 whole divided by s plus 2 the whole square plus 16 the whole square. That's it. So finally the answer for this will be 8s plus 16. If you want to leave as it is, you can leave or simplify. It is better. 8s plus 16 divided by s plus 2 the whole square is s square plus 4s plus 4 plus 16 is 20 whole square. That's my answer. That's it. Okay, see how beautiful it is. Understood? This is how we solve it step by step. So they can give any questions here. It can be t into e raised to 4t cos 3t. So same way, first take always e first, then start solving according to property. Okay, here sine 40, property 2 and property 1. That's it, as simple as that. Now there is one more question here, see. Again here, this is also easy question only, but little confusing. Why? Because see, there is something given 0 to infinity. Okay. Evaluate 0 to infinity t into e raised to minus 3t into cos 2t dt. So let's solve this question. See, can you tell me which property it belongs? See, this is not any property. In the beginning of Laplace, while discussing Laplace basics, I have given you the first formula. Laplace transform of any function is defined as Lf of t is equal to 0 to infinity e raised to minus tf of t dt. Okay, so that is what again? The formula. So we have Laplace of f of t is defined as 0 to infinity e raised to minus st into f of t dt. See here. There's the one more thing. See, Laplace of property 3, anything by t is s to infinity, that's different. Here is 0 to infinity. 0 to infinity resembles the basic formula of Laplace, that is Lf of t is equal to 0 to infinity e raised to minus st into f of t dt. Fine. Now, how to solve this? It's very simple. Just let's compare it. Here see, 0 to infinity t e raised to minus t cos 2t. So what I told, wherever e is involved, always take it first. Things will become more easier for you to solve. Always do it. Otherwise, you will be confused yourself. So now, here again I rewrite this as, so 0 to infinity e raised to minus 3t into t cos 2t dt. Now, if you see here carefully, see here into f of t. See, this whole thing will be what? F of t. E raised to, if you see here, e raised to, what this? E raised to minus st. And here, if you compare this, you see that s is equal to what? 3. What's s is equal to? 3. So my s is equal to what? 3 here. E raised to minus 3t into t cos 2t to dt. E raised to minus st into f of t. Compare the formula. F of t is this whole thing, t cos t 2t, and e raised to minus st. Minus st e raised to minus 3t. See, minus s minus 3. S is equal to what? 3 here. So this is the main thing we need here. So once you have this, simply find the Laplace of this. So Laplace of t cos 2t will be what? Simply find Laplace of this, and in the answer, what to do? I write here, find Laplace of this, and then in answer replace s is equal to what? 3. That's it. So let's solve the Laplace of it. Solve the Laplace of t cos 2t. Again, property 2. Laplace of t raised to n into f of t is equal to minus 1 raised to n d raised to n by ds raised to n into Laplace of f of t. So here again it is minus 1 raised to 1 d by ds of s by s square plus 4y, because Laplace of cos a t is s square plus s square. So this is again now minus outside the bracket, again is the quotient rule appropriately. So denominator square, denominator as it is, second function as it is, differential s is 1 minus s as it is. See here s is there. Previous case it was 4, differential of 4 is 0, constant, but here s is there, differential of s is 1, s as it is, again differential second function square plus 4 is 2s, s square is 2s. That's it. So this will be now minus s square plus 4 minus 2s square whole divided by s square plus 4 the whole square. So this will be again now, see, I write here s square minus 2s square, 4 as it is, see, minus 4 as it is, s square minus 2s square will be minus s square, minus s square divided by s square plus 4 the whole square. So now open the bracket, minus into minus plus, so final answer for this will be 4 plus s square, or I write this as s square plus 4, sorry, s square minus into minus is plus, minus 4 divided by s square plus 4 the whole square. And finally what we need to do here, see, minus into minus plus s square minus 4 upon whole square, and finally what we need to do, we replace, put s is equal to what? 3. So you put s is equal to 3 here in the answer. 3 square is 9. So we have 9 minus 4 by 9 plus 4 the whole square. So the final answer is 9 minus 4 is 5 divided by 9 plus 4 is 13. The square of 13 is 169. That's the answer. So, the answer for 0 to infinity t e raised to minus 3t cos 2t dt is nothing but 5 by 169, and there is no property here. This is the general basic formula for Laplace, that is Laplace f of t is equal to 0 to infinity e raised to minus t f of t dt. So, find yes, compare both the question given and the first time property, find yes whatever is next to it, that is f of t, find a Laplace using the properties, and then replace the answer by whatever is here. That's it, as simple as that. Understood? So dear friends, that's all for today's video. If you find this video helpful, then please make sure to like the video, share with your friends and classmates as much as possible during these difficult exam times, and the most important, subscribe to the channel for more exam focused content. Now stay consistent, keep practicing, and remember, difficult problems are very easy to solve only when you understand the concept clearly. Okay, so I will see you in the next video. Till then, keep learning, keep growing. Bye.